Hello everybody, and welcome back to another math video on my channel. Today we will be talking about the fundamental theorem of calculus, or FTC. This is one of the most important things in all of calculus, but is not very difficult to understand and is often covered in most elementary calculus courses. Thus, its placement is over here. The reason I didn't cover it immediately when I was doing differentiation, as this requires both differentiation and integration to be known before this can be explained. So without further ado, let's move on to the video. The unique thing about the fundamental theorem of calculus is it comes in two parts, part 1 and part 2. But the thing is, oftentimes we will be explaining part 2 before part 1 because part 2 is a prerequisite or something that you must know before actually learning that topic. Also, this has many parallels with something known as the fundamental theorem of algebra, which states that a polynomial of a0 x to the n plus a1 x to the power of x minus 1 plus so on until a of n minus 1 multiplied by x then plus an is equal to 0 has exactly n solutions accounting for complex numbers and duplicity, which basically means if there's any repeated roots, or basically if we had like x squared plus 2x plus 1 is equal to 0, it technically has one root, but according to the fundamental theorem of algebra, it has two because this is a repeated root. But enough talking about the fundamental theorem of algebra, let's start talking about what we came for, which is the fundamental theorem of calculus. As I explained earlier in the video, part 2 is a prerequisite to part 1, and we will be explaining part 2 first, as part 2 lays the foundation for part 1. Now, the second part of the fundamental theorem of calculus states that if we have an integral from a to b of f of x dx, and the antiderivative, or another way to say an integral, so antiderivative of f of x is the capital F of x, then this is equal to f of b minus f of a. Now you might know this as something else, as the definition of a definite integral. And if you said that, you would be exactly right, because the second part says that this is the definition of a definite integral. With the second part of the fundamental theorem of calculus out of the way, we can move on to the first part, except one more thing. Also, when the antiderivative is there, that means f dash of x, or the derivative of the capital F of x, is equal to f of x. And this was covered in my previous video, but I think many people tend to forget this and think that the antiderivative is something new, although it is just the integral, and these two are the same, and antiderivative is interchangeable with integral. Now we really have the second part of the fundamental theorem of calculus out of the way. Let's now cover the first part. Over here we have part 1 of the fundamental theorem of calculus. This states that if we have an integral from a to x, let me redraw that so there's a little more space. We have an integral from a to x of f of t dt, and this is equal to capital F of x, then the derivative of this capital F of x is equal to just the original function f of x. Now, this actually makes a lot of sense since capital F of t is the antiderivative of f of t, and if we take that, then we have f of t, then f of t, but then t gets replaced with x because of the part 2 of the fundamental theorem of calculus, and that's why I explained part 2 before part 1, and then f of x minus f capital of a. Now, a is a constant. A and b are always constants when we cover these types of definitions. So, since f of a is a constant, if we take the antiderivative of this, that means we get f dash x, and we don't get anything else. And since when you take the integral of this from a to x, a anyway cancels out, and you have the x, which you substitute into, that's equal to f of x. So that's a short derivation of part 1 of the fundamental theorem of calculus versus part 2 of the fundamental theorem of calculus, and that's why we cover part 2 first. So if you enjoyed this video, please consider giving it a like, hit that notification bell, and make sure to subscribe to my channel for more awesome videos just like this. And if you have any other suggestions, comments, or just thanks for these videos, please make sure to go down in the comment section and comment down below. So I always read every single comment and try to respond as best as I can so I can improve my channel for myself and for all of you, the viewers. So thank you so much for watching this video. See you in the next one, and bye-bye.